couple of very important features of C# are things known as delegates and events. And although most programs will be using these very frequently, I tend to find, particularly when I'm teaching, that a lot of people don't really understand the fundamentals of how they work. So what I'm going to do here is look at those. I'm going to split this into two videos as so often. So we're going to look at delegates in this video and then move on to the very closely related area of events in the next one. But for now, let's take a look at this program I've put together. So it's very, very simple. It's a program that is going to plot a sine curve. So we've got a function here called plot sine, and it takes some parameters. x0 and x1 are defining the range of x values that we're going to work across, and then dx is going to define the step between each one. So there we have our for loop going through from x0 to x1 in steps of dx. And then we just use math.sine to work out the y value for the corresponding x value. And I said we're going to plot it. We're not actually going to spend time doing any graphics. It's just going to display that as some formatted numbers. And then in main, we say we're going to plot sine from 0 through to pi on 2 in radians, which is 90 degrees, with a step of 0.01. And if we run that up, then we can see we get exactly what we'd expect. If you can remember from your basic mathematics, sine of 0 is 0, so that's what we've got at the beginning, and then sine of 90 degrees is 1, so that's what we've got at the end there. So exactly what we'd expect. So it's a program that works, but it's somewhat limited in that we'll only calculate sines. And if we wanted to extend this and have a program that would plot cosine, or indeed plot any kind of function of x and y, then we'd find, if we approach this in a naive way, that we're doing a lot of copy and paste, because basically we could take that function, copy it, paste it, rename it plot cosine, but then the only difference would be just at that point there, we would be saying math.cos rather than math.sine. So it'd be a lot of duplication, not really what we want to do. What would be really nice would be if we could actually pass in as a parameter to the function, in the same way that we can pass in numbers, if we could actually pass in the function that we want to plot the graph for. So we can actually say use sine or use cos or whatever. And that is exactly what delegates will do for it. Because if I firstly declare a delegate, so what I can do is up here I could say public and then use the keyword delegate and then specify what the function should look like. So for the function we want, it's going to return a double. We're then going to call the delegate maths function, and then we're going to specify that it also takes a double, and we'll call that x. So the name doesn't matter much, it's the type that's important. But that's all we need to do to declare a delegate. So it's a new type, so it can be declared directly inside a namespace, just like classes and so forth. You can make it public or internal if you wanted to, but the key thing is we've declared this new type called maths function. And like any other type, we can use it as a parameter type, we can use it to declare a variable, we can use it to declare a field or a return type, or absolutely anything we like. So we're going to use that to declare a parameter. So we're going to have a parameter called f of type maths function. And then this is no longer going to be plot sine, so let's just call this plot. And down here we'll call it plot. And then we pass in as that first parameter the function that we want to plot, which in the new case we said was going to be math.cos. So you can see, because cos, if you look it up, takes a double and returns a double, and because maths function says we take a double and return a double, then that's going to pass in okay. If I tried some other function, like if I say tried a tan 2, which happens to take two doubles, then that doesn't match up with that specification, so we're not allowed to put it in there. So the compiler is very strict that whatever we put in there has to match the specification. But apart from that, it can be any function we like. And the other thing to notice that's happening here is we are not actually invoking the cosine function at that point. We haven't put any round brackets on there. We're simply passing it in, so it's containing a reference to the actual function, which hasn't yet been executed. And then the point we want to execute it is where we previously had the sine, and so we can just say f, and again, because f is something that takes a double and returns a double, we can pass our value x in there and get our value y out. And then this cosine that we've passed in there is going to be called repeatedly on each iteration of the loop. So when we run that up, we can see, again, if you remember from basic maths, we now have the cosine of 90 is 0 and the cosine of 0 is 1. So that's worked correctly. And then having done that, we're now in a situation where we can plot absolutely any function we like as long as it takes a double and returns a double. So there are lots of these that we've got available in the maths library itself. So if I wanted to do something like square root, I can pop that in there, matches the specification. And so now, do the maths if you want to, we can see that we're getting the square root of each of those values. Or if I went for something like tan, then again, we'll get the results. Bear in mind, tan explodes at 90 degrees. So that's just starting to happen. We're not quite getting there. But also, I could write my own function. So as long as it matches that specification, we can do that as well if we want to. So let's say static double x. What's it going to do? It's going to double x. So return x times 2. And then I could just take that double, pop that straight in there. Again, it fulfills that maths function specification. And so now if I run that, I'll simply get a graph doubling the value of x each time. So very, very useful, very flexible, just means that we can use this same function layout again and again and again and just change that little bit of what it actually does. But if we take a look at this double, we might start to immediately realize, well, even here, we've got this similar problem of code duplication, because if I wanted to maybe do a triple function, I would find that I was writing that out. I'd call that triple, and then I would do multiply by 3 in there. And although I could pass that triple in and get it to work, you can see there's a lot of code duplication. The only difference between these two functions is really what's at the very heart of it, there and there, and yet I've got to put all that boilerplate code around there to make them work. What would be really nice is if I could simply pass in there directly something like x times 2 or x times 3 or whatever I want. But we can see we're getting a compilation error there, but we can get very close to that, because what we can do is say x arrow x times 2. And that is an example of a lambda expression. And by doing that, we no longer need to have our double or our triple. We can see that if I do that, we get the doubling. And if I simply change that to 3, we get tripling. Or if I wanted to put any functionality I like in there, x minus 1, then we get x minus 1 being calculated each and every time. So that's what we've got there, and that's what a lambda is. A lambda is simply a shorthand way of declaring a function anonymously that matches a particular specification. So that lambda expression there, x gives x times 2, that's normally the way I'd read that symbol, just as gives, is exactly the same as the function double, but much, much more concise. If we just break it down and analyze it, the thing on the left of the arrow, the x, is the parameter list. So where we have the full parameter list there, double x, we've just got x here, because in almost every situation, a lambda will be able to implicitly work out the type. So if we hover over x, we can see it's worked out that it's a double. How does it know it's a double? Well, it knows it's a double because we're passing into maths function, and maths function takes a double, and so it's worked that out. Just occasionally, you might find you have to use explicit typing, which you can do. You've got to put brackets around it there. And so now we're explicitly saying that x is of type double, but in the vast majority of cases, it just infers it for you. So that's what we've got on the left-hand side. If you had, in a different situation, multiple parameters, then down here, you could just comma separate them. Again, remember to put them in round brackets. Obviously, it doesn't work there, but if your delegate had been set up with 2 parameters, it would infer the type from them. So that's the left-hand side of the arrow. And then on the right-hand side of the arrow, you simply have the body missing the return statement, because lambdas are so often used to return a value, we don't need to bother with the return. we put that on there. Again, if things get more complicated, you could put the return on there. You could put multiple statements in there. If you do anything like that, you've got to put a set of curly braces in there. But if it's just a single return statement, you can do it in that very, very brief way of just saying the expression you want to return and not having to worry about the return keyword. So that's what we've got there. That's all a lambda is. A lambda is just a shorthand way of writing and passing an anonymous function to a delegate. What's on the left is the parameter list. What's on the right is the return expression. A few more things we can say about that. One is to bear in mind that delegates are always potentially multicast. And what that means is, rather than simply putting one function into our delegate, which is what we're doing here, we could actually put in more than one function. So if I were to do something like this, if I were to say math function f equals math dot sine, I could then say f plus equals math dot cos, and then f plus equals double. I can also do minus equals if I want to remove one of those from the list, but let's just leave it with plus equals for now. And what will happen if I then execute that? So if I just say something like double result equals f of 2, then it will simply execute each of the three functions in the order I've declared them. So it'll do the sine and then the cos and then the double. But then the slightly odd thing here, which is why in these circumstances we don't really do that, it can only return one value. So each three of those functions has returned its own calculation, but all it does is returns the last one. So if I were to print out that result, it would simply be the result of the double. And so you can see we just get the value of 4. Whereas if I took that one off, then we're getting, that happens to be the cosine of 2. So in this sort of case, when you're returning a value, actually using this idea of a multicast delegate isn't much use. But if we wanted to, say, pop out a message, so if we say had our double and our triple, we could in here maybe do console write tripling, in here do console write doubling, and then if we did plus equals triple and plus equals double, then the result would still be the double, but we'll see that both of them are getting executed. So multicast delegates actually more commonly used when you've got a void return type, when you don't care about what's coming back. And that's what's usually happening with events that we're going to look at later on. When you've got a value coming back, then you only want one of those, so normally you'll just use a single cast delegate. One other thing to look at here is if we take a look at the declaration of our delegate, our maths function up there, that's something that you'll quite commonly see done, and that would be useful if maths function is going to be used again and again and again and again all over your program, or maybe put it in a library so other people can use it. Here though, it's just a one-off. We're only using maths function in one place, and so you could regard it as a bit of an overhead to have that separate declaration. So what we've also got available to us are what are known as generic delegates. And so what I could do is I could get rid of that completely, and in here simply put func and then double double. And so what that is doing is on the fly declaring a delegate that takes a double and returns a double. So effectively it's doing exactly the same thing as we've got there, but just like with a lambda we could have an anonymous function, here we can have an anonymous delegate, and it saves us the time of doing a separate declaration. But you can see we can still pass either a lambda, or we could have passed one of our functions in there. It's doing exactly the same thing and behaving in the same way. Thing to watch out there that is slightly confusing is the order of those two doubles. So let's just put in a few examples so you can see what I mean. So if I had something slightly different where maybe my return type and my parameter weren't the same, then we can see something. Let's just say we have a delegate, we'll call this D1, and takes a double, returns an int. The equivalent generic delegate would be func and then double comma int, and we'll just call that something like D1. So you can see the important thing to remember is the return type is always the last one in the list. So however many parameters you have, you put those first and then you put the return type last. So let's just go with a different example. So let's suppose we had a public delegate D2 double X string S, then that would be the equivalent of func, and then that would be double comma string comma the return type int. And so that's what we've got available there. You'll notice if we just have a look at what's available there, we've got predefined 17 different overloads for this. There's no mechanism in C# whereby this can be written in a completely general purpose way. So the library actually defines 17 overloads, so we're allowed up to 16 parameters and the return type. If you ever need more than that, you should really be asking yourself whether you've designed your program properly. But if you have got a good reason, you could always write a generic func for yourself to go beyond that. But I don't think anyone's really ever going to hit beyond that. But that's what we've got to make that work. One other thing to watch out for, if we had, say, something like this, so public delegate with a void return type, D3, and then let's just put int I in there, you might be tempted to try to implement that like this, to say we've got a func, we've got a parameter type of int, and then we've got a return type of void. But you can see it's objecting to that because void isn't really a type in C#, it's something slightly different, but it's not allowed in these circumstances. So if you want to have a delegate for something that returns void, actually we have a completely different generic, which is simply action. So action always returns a void, and then the int and whatever other types we have in there are just our parameter list. So I've just got there a few examples of how we can map a declared delegate with a name, capital D1, D2 and D3, onto one of these generic delegates, which in many, many cases will just save us a bit of effort. So really pretty simple stuff. We've seen a number of ideas there. We've seen the idea of a delegate, a new type that we declare, into which we can put a function as long as that function has the correct return type and parameter types. We've seen also that delegates are multicast, so you can actually put multiple functions into a single delegate, and then when you invoke the delegate, they'll be called in sequence that you added them to the list. We also saw that doesn't necessarily make much sense in terms of return values, but in terms of delegates with a return type of void that actually do something, that can be very useful to do multiple things on a single delegate invocation. We also saw how we have lambdas, which are a shorthand way of declaring an anonymous function that then typically gets passed into a delegate. And then finally, we saw that we can have these generic delegates, so func and action, to save us, in a lot of cases, actually declaring fully blown delegates up front. More on that in the next video on events and how they relate to delegates, but I hope that's been helpful.